In this video, we're going to look at how to name and draw alkenes and alkynes. Alkenes are hydrocarbons that contain at least one carbon-carbon double bond, and the names of alkenes end with ene. So we're going to use those prefixes that tell us how many carbons are in each hydrocarbon, and then we'll add an ene ending to it, and that'll tell us that it's an alkene. Alkynes contain at least one carbon-carbon triple bond, and their names end with a yne. So let's look at this example here and figure out how to name it. The first step you want to do is the same as when we're naming alkanes, and that is to find the longest continuous chain. The thing is, for alkenes and alkynes, that longest continuous chain is the longest continuous chain that contains both carbons involved in that double or triple bond. So for the example that is here, our longest continuous chain is going to start here. We have our two carbons in the double bond, goes along, and then it takes a turn up here and includes that carbon as well. So that's our longest continuous chain. Now, when we number it, we are more concerned with the double bond or triple bond having the lowest number possible versus the substituents that we were concerned about for alkane. So our functional group, in this case our double bond, is going to have priority. And so in that case, we're going to start numbering on this side, giving that carbon 1, carbon 2, carbon 3, 4, and 5. Okay, so that gives our double bond between carbons 1 and 2. And we have 5 carbons in our longest chain. We have a double bond. So the last name of this is going to be pentene. But for alkenes and alkynes, we need to include a number in front that tells us where that double bond starts. And so it's going to be the lowest of the two numbers where between the carbons. So in this case, it's going to be a 1 pentene, telling us that that double bond starts between carbon 1. So it's going to be between carbon 1 and carbon 2. Okay, now let's name our substituents. We have a methyl group up here, so this is a 3-methyl. It's off of the third carbon in our chain. And we have a chloro group down here, and it is also a 3 off of the third carbon in the chain. Okay, we're going to add those prefixes, those substituents as prefixes to our name in alphabetical order. So the 3-chloro comes first. So 3-chloro, 3 methyl, 1 pentene. Let's look at another example. In this example, we're going to look at an alkyne. It has a carbon-carbon triple bond. We'll find our longest continuous chain. I'm going to circle it so we can see what is our chain, main chain, and what is our substituents there. Okay, so there's our longest continuous chain that contains both carbons that are involved in that triple bond. Now we want to name it, giving those carbons in the triple bond the lowest numbers possible. So I'm going to start on the left, and this will be carbon 1, 2, 3, 4, 5, and 6. So we have 6 carbons in our longest chain. That would be a hexyne with a yne ending to it. And the prefix or the number that we're going to use is going to be the number 2 because that's the lowest number for where the carbon where the triple bond is. So it's going to be a 2 hexyne with a yne ending to it. So the hex part tells us there's 6 carbons, yne ending tells it's a triple bond. The 2 tells us where that bond starts, that triple bond starts. Okay, now let's look at the substituents. Once we have circled our main chain, the things hanging off are the substituents. So we have a methyl group off of the 4th carbon and a methyl group off of the 5th carbon. So since we have 2 of the same groups, we use a prefix di, so that's a dimethyl. Since we have 2 groups, we have to have 2 numbers. In this case, it is 4, 5 dimethyl, and that becomes our prefix for our name, 4, 5 dash dimethyl, and then a dash between the 2. So 4, 5 dimethyl 2-hexyne. Let's look at drawing alkenes and alkynes. So here's our first one that we're going to do. Draw the condensed structure of 4-ethyl 2,2-dimethyl 3-hexene. Now, this is asking for the condensed structure, but especially at the beginning when you're learning how to do this, go ahead and write out the expanded structure. That way you make sure that you get the number of hydrogens correct. Now, when we are drawing the structure from the name, you start by kind of the last name or the last part here, because that tells us the main carbon chain, how many carbons are in it. So a 3-hexene tells us that it has 6 carbons and it has a double bond starting at carbon number 3. So I'm going to start out by writing my 6 carbons. And off of, or between carbon 3 and 4, I'm going to put in a double bond. So that takes care of the 3-hexene part. Now I'm going to work my way back, and the next thing is a 2,2-dimethyl. So that means that off of the second carbon, I have 2 methyl groups. So I'm going to draw one on top and one on bottom. That's my 2,2-dimethyl. And the last one is a 4-ethyl. An ethyl group is a 2-carbon chain, and it's going to be off of the 4th carbon. So I'm going to write that here, CH2, CH3. Okay, the last thing to do is add in our hydrogens so that each carbon is making a total of 4 bonds. And then from that, we will draw the condensed structure. So carbon number 1 here needs 3 hydrogen. Carbon number 2 doesn't need any more hydrogen because it's already making 4 bonds. Carbon number 3 is making a total of 3 bonds, so you can draw 1 hydrogen. You can either draw it up or down, it doesn't matter. Carbon number 4 has already 4 bonds, 2 for the double bond, 1 to the other carbon, and then 1 to the substituent. So we're not adding any hydrogens to that. Carbon number 5 needs 2 hydrogens. I'll draw 1 up, 1 down, and then the last carbon needs 3 hydrogens. Okay, now based on that, let's draw the condensed. So carbon number 1 over there has 3 hydrogens, so that's going to be a CH3. Carbon 2 has my methyl groups on it, so I'm just going to draw 1 up and 1 on top. I'm just going to leave those right there. And then carbon 3 is a CH. It's bonding to 1 hydrogen, double bonded to the next carbon, which has the ethyl group coming off of it. No hydrogens though off of carbon number 4, and then carbon 5 has 2 hydrogens and the last carbon has 3. So that would be the condensed structural formula for 4-ethyl 2,2-dimethyl 3-hexene. Let's look at one more example. Here we have draw the condensed structure of 4-methyl 2-pentyne. So again, just like before, we're going to start with our main chain. So that's the last part of this name. Pent tells us there are 5 carbons. The Y-N-E ending tells us that it has a triple bond, and that triple bond starts at carbon number 2. So I'm going to write 5 carbons out. 1, 2, 3, 4, 5. So between carbon 2 and 3 is a triple bond. So I'm going to add in the triple bond. That takes care of the 2-pentyne. Now for our substituent, 4-methyl. So off of the 4th carbon, I'm going to put a methyl group. And so now we're going to just add our hydrogens. The first carbon, it needs 3 hydrogens. Carbon number 2 is already making 4 bonds, with 3 being the triple bond and then the 4th bond to the first carbon. Same with carbon 3, it's already got 4 bonds. So carbon 4 needs just 1 hydrogen, and then the last carbon needs 3 hydrogens. Okay, so now drawing the condensed structure, carbon 1 is a CH3, and that's bonding to a C with no hydrogens, triple bonding to another carbon with no hydrogens. That bonds to a carbon with 1 hydrogen and a methyl group off of it. So I'm going to draw that up as my substituent, and then we end with a CH3 group. And that is the condensed structural formula. So remember, when you are drawing them and it's asking for the condensed structure, go ahead and draw the expanded first. That way you can make sure that each carbon has the correct number of bonds. Make sure you count that so that the carbon isn't making more than 4 bonds.